The coaxial cable was invented by Oliver Heaviside in 1880. Let's find the inductance per unit length for a coax cable. The coax consists of a center conductor surrounded by an outer conductor. So current flowing down the center conductor will return through the outer conductor. Here is a cross-section through the coaxial cable with the center conductor along the z-axis. From the symmetry, we know this will be the form of the magnetic field intensity. Let's apply Ampere's circular law to an Amperian loop between the two conductors. Our magnetic field intensity will be constant everywhere on our Amperian loop, so the integral of H dot dl will just be the magnetic field intensity times the circumference of our Amperian loop. So between the conductors, the magnetic field intensity is I over 2 pi rho. Outside the coaxial cable, there is no magnetic field intensity because the magnetic field intensities coming from the currents flowing on the inner and outer conductor will cancel because those currents are flowing in opposite directions. Multiplying by the permeability of the material between the two conductors, we get the magnetic flux density field inside our coaxial cable. Our magnetic flux density field will be coming out of the page above the center conductor and into the page below the center conductor. We'll find the inductance of a segment of length L and divide by that length L to get the inductance per unit length. Since the flux coming out of the page above the center conductor is the same flux going into the page below the center conductor, we just have to find the flux through this surface S here. So to get the total flux, we just integrate B dot ds over this surface S. So here is our differential surface. It will be of area d rho times dz, and the outer normal will be in the phi direction. So we'll substitute for B and ds. And in the rho direction, we'll integrate from A to B. And in the z direction, we'll integrate from 0 to L. A phi dot A phi is 1. So let's factor out the constants to get mu I over 2 pi. Integral from 0 to L of dz, and then the integral from A to B of d rho over rho. The integral of d rho over rho from A to B will just be the natural log of B over A, and the integral of dz from 0 to L will just be L. So here we have the total flux associated with this segment of length L, and in this case the flux will be the same as the flux linkage. So to get the inductance for this length L of our coaxial cable, we divide our flux by our current I, and here's the expression for that inductance. So to get the inductance per unit length, we take our inductance for our segment of length L and divide by L. So the inductance per unit length for our coaxial cable is mu over 2 pi times the natural log of B over A.